So if we can get the local skin friction at the trailing edge and we have a flow in this direction, then get the local skin friction coefficient at the trailing edge multiplied by 2 will give us the average skin friction coefficient. So average skin friction coefficient also can be written in terms of Reynolds number is equal to 1.292 REL raised to half. So with the help of REL, which will be equal to REL is equal to what? Rho u infinity multiplied by L. L is the length of the plate in the direction of the flow divided by mu. Substitute here, multiplied by this, we will get Cf bar. Once we get Cf bar, we can get the drag. So in this manner, we can get the drag value. So earlier, before 1904, earlier to 1904, it was not possible to calculate the drag analytically. With the help of these approaches of the boundary layer, we were able to solve the mathematical equations and we could give answer analytically to these questions like what is the drag, what is the boundary layer thickness at different locations. Otherwise, we used to conduct experiment to give the answer of this question, that what is the drag force on this flat plate. Then we have concept of displacement thickness, momentum thickness, but before going for displacement thickness definition and boundary layer thickness like momentum thickness, I would like to show you some videos. When we discussed the chapter of pi flow, at that time we studied the concept of boundary layer also. At that time I had shown you some of the videos, but today we shall discuss about the very important concept which is known as separation of boundary layer. So in this video, we have a flow taking place in x direction and we have a aerofoil. When we have a flow, then you can visualize the shape of the flow, and if we change the angle, then what happens to the flow, we can visualize it. In the downstream side, we are visualizing some eddies formation, or it is known as wake. Boundary layer is said to be separated, and as we have more angle of attack, we have more unsteady flow in the downstream side. Though we have a steady flow, a constant fluid flow is there over this aerofoil, but in the back of the aerofoil, due to separation, we have a separated fluid flow which causes very huge resistance. So at different angle you can visualize. Now in this video we have inviscid flow. Inviscid flow means when viscosity of the fluid is assumed to be 0. When viscosity of the fluid is assumed to be 0, in that case if we solve the problem for finding out the pressure at different location for flow over a cylinder, in that case we will find that these are the high pressure zone. Here with the help of this circle, means this area and this area, these two come in the category of high pressure zone, and these two pressure come in the zone of low pressure. Because when fluid is flowing in this direction from left to right, in that case this is the portion where we have a solid surface. Because of the solid surface, the net area is reduced. When net area is reduced, then what happens to velocity? Velocity is increased. When velocity is increased, then pressure is changed, right? But there is no separation. So whatever pressure is here, the same pressure is here, and whatever pressure is here, the same pressure is here, and this cylinder is not subjected to any force due to pressure difference. Now if we observe what happens to when real fluid flows over a cylinder, this is another type of video in which what happens when fluid is flowing from left to right. In that case what happens, after this point these boundary, they can't remain stick to surface because of the energy. So what happens, they get separated. So at this is the location where we have separation. Here we have boundary layer gets separated, or fluid is said to have separated from the boundary. Because of the separation, the right hand side, the pressure recovery is not achieved, because kinetic energy was supposed to be converted into pressure energy, so it is not being converted. So when it is not being converted into pressure energy, then right hand side we have different pressure than the left hand side, and when because of this situation we have very large force. Now that can be visualized with the help of this figure also. In this figure we have a car and we have a hill of symmetric nature. With the help of this we can easily understand the boundary layer separation, and when it is separated, then pressure recovery, means kinetic energy is not converted into potential energy. And we know what is the pressure energy. Pressure head plus potential head is known as piezometric head, right? So when there is no friction, in that case this car will come back to its position, which is symmetric, and it will reach at the top of the hill. If we have no friction, there is no friction, in that case this car will not reach to right hand side, this car will reach up to this height only. So it means that because of the friction some energy is lost, so that's why it will reach up to this point only. When there is no friction, then it will reach up to this point. So whole kinetic energy is converted into potential energy. But if there is a friction, then some energy is lost, and so that's why this will not reach to this point, it will reach up to this point only. So separation plays very important role in both the flow, internal flows or as well as external flows.